All right, so in the last lesson that we did, we learned about our rational expressions. We learned about what makes something rational, a rational number, all those good things. So today we're going to really get into what a rational function is. And we had expressed that a rational function was anything that was in the form y equals p over q, right? Because p over q, this is what a rational number is, anything that's a fraction. But the problem that we run into with rational functions is that hopefully we remember when we have a fraction, the denominator can never be 0. So we do run into a bit of an issue here. So when we're working with functions, we know that a function has to work, has to be able to exist. But because rational expressions or rational functions are working with fractions here, there are a couple of parts that don't really work. So let's just, for example, let's work with the function y equals, we'll go with negative 2 over x. Because remember, the only part of the function we're changing is this top value. This is our k, okay? So in this case, my k would be negative 2. Now, like we just said, x can be any number. This is a variable. We can replace it with any number, including 0. But when we put 0 here, this becomes nothing. We can't have a 0 in the denominator. So whenever we're working with rational functions, we have to, before we do anything, we have to state any what we call excluded values. Okay, so today we're going to be looking at excluded values. And like we said, an excluded value is just something that within the function would not work, right? So in the example here, y equals negative 2 over x, what would my excluded value be? Well, all I do is I take the entire denominator, in this case my entire denominator is just x, I take that whole thing and I set it equal to 0, and then I would solve. Now again, in the case of this first one, setting it equal to 0, it's just x equals 0. So my only excluded value for y equals negative 2 over x is that, well, x cannot equal 0. This is an excluded value. X equals 0. Okay? Now, it does get a little more complicated, obviously, with the denominator changing. Let's say I wanted to determine what the excluded value of the function y equals 2 over x plus 1 is. Okay? So again, if I wanted to figure out what my excluded value was here, all I'm going to do is I'm going to take the entire denominator, this whole thing here, and I'm going to say, well, I know that I don't want this to equal 0, so let's figure out what it is if it does equal 0. So I'm going to take the entire denominator, x plus 1, I'm going to set it equal to 0, and then I'm just going to solve this. So again, in order to solve this, it's just subtract 1 from both sides. So I get x is equal to negative 1. So my excluded value would just be negative 1. So that's really all you have to do to find your excluded value. Take the denominator, the entire thing, set it equal to 0, and then solve, and that'll give you the excluded value. Let's just do one more real quick. Let's say that we had the function, here, and I'll get rid of this over here. Let's say we had the function y equals 5 over 4x minus 8. And again, I say, all right, here's my rational function. Let's determine what my excluded value is. Okay? Like we said, I'm going to take the entire denominator, the whole thing, whatever's in the bottom. I'm going to set it equal to 0, and then I'm going to solve it. So in order to solve this, I'm going to add 8 to both sides. So I have 4x is equal to 0. Equal to 8. Divide both sides by 4. And I'm going to get x is equal to 2. So in this function here, my excluded value would be x equals 2. Okay, so again, I've given you 3 different functions here. Take about 5 minutes, pause the video, and see if you can find the excluded values for each one of these 3 functions. Remember, to find the excluded value, you're taking the entire denominator, setting it equal to 0, and solving it. So go ahead, pause the video, take 5 minutes, try and do those 3. Okay, so for the first one, we take the 2x, set it equal to 0, divide both sides by 2, and we still get x is equal to 0. So my excluded value would be x is equal to 0. Over here, again, take the denominator, set it equal to 0, add 7 to both sides. My excluded value would be x is equal to 7. For the last one, take the entire denominator, set it equal to 0, solve. We would get the excluded value of x is equal to negative 3. Okay, so the next part of this, if you remember on the last video, we talked about what the graph of a rational function was, right? And we said that the graph of a rational function looked something similar to this, right? We had something like this. And then on the other side, it was like this. Okay. Now, if we notice, this is very similar to when we talked about exponential functions. We said it kind of looked like 2 exponential functions put together. But just like with exponential functions, this graph has asymptotes. Okay. If you don't remember what an asymptote is, we did talk about this back in when we were talking about our exponential functions. But an asymptote is a line that the graph of a function approaches, or it gets closer and closer and closer to, but never touches. Now, in this graph, we actually have 2 different asymptotes. Right? There's one of our asymptotes. And there's the other asymptote. See how the graph gets closer and closer to that blue dotted line, but it'll never cross it. It'll never touch it. Same with over here. It's going to get closer and closer to both of these blue dotted lines, but never cross it. That's what an asymptote is. So for all rational functions, you actually have 2 different asymptotes. You are going to have a vertical asymptote and a horizontal asymptote. Okay, obviously the vertical asymptote is the vertical line here, the up and down, and the horizontal asymptote is the horizontal line, the left and right. So we have to be able to determine where my asymptotes are, because if I know where the asymptotes are, graphing it's really easy. Okay, obviously we would know that in the one corner it would get closer and closer to both of the asymptotes that way. In the other one, it would get closer and closer to them that way. So once we know our asymptotes and how to find the asymptotes, it makes graphing this extremely simple. So that's what we want to do right now. We want to determine where are the asymptotes in any rational expression. Well, if we look at the form of any rational expression, the form of a rational expression is y equals a over x minus b plus c. Okay? We know for a fact that x can never be 0, right? And we've solved, just in the previous part of this video, how to determine what that excluded value is. Well, guess what? That is your vertical asymptote. The vertical asymptote is just taking the denominator, setting it equal to 0, and solving. Okay? So in this case, it would just be x is equal to b. This is your vertical asymptote. So what we were doing before, that's how you find your vertical asymptote. Take the denominator, set it equal to 0, solve, that's your vertical asymptote. The horizontal asymptote is just as easy. Your horizontal asymptote is just whatever is out here, whatever C is, whatever you're adding or subtracting to the end or to the beginning of your fraction. So my horizontal asymptote would just be y equals C. That is the horizontal asymptote. Okay, and obviously if there's nothing out here, then it's just 0. So these are the two things that we want to look at when finding our asymptotes. So let's get a little bit of practice with this. So let's say I wanted to identify the asymptotes of the function y equals 2 over x minus 4. All right, so if I wanted to figure out what the asymptotes for this were, all I'm going to do is I'm going to find my vertical and my horizontal. So we'll start with our vertical asymptote. And if you remember, the vertical asymptote is take the denominator, set it equal to 0, and solve. Now in this case, I don't have to solve anything. X is already by itself. So that means that my vertical asymptote is x equals 0. That is the vertical asymptote, and we're finished. The horizontal asymptote, I take whatever is being added or subtracted on to the end of the function. So in this case, it's the negative 4. And my horizontal asymptote is going to be y equals negative 4. There are my two asymptotes. It's as simple as that. Take the denominator, set it equal to 0. That's the x equals. Take whatever's added or subtracted to the end, set that equal to y. That's the horizontal. Now, like I said, we're going to look to graph this, okay? But once we know where our vertical and horizontal asymptote are, it's actually really simple to graph. So if I go to graph this function, the first thing I'm going to want to do is I'm going to want to graph my horizontal and my vertical asymptotes. Okay, so I'm going to first do the vertical asymptote. So where x is equal to 0, remember, this is my x-axis. So I'm going to go to where x is equal to 0, which is right here. All right, and we know that a vertical line is an up and down line. So at the point x equals 0, I'm going to make a dotted line going up and down. I know it may be a little hard to see, but hopefully you can see that. All right, so I make a vertical asymptote at x equals 0. Now I'm going to do the same thing for the horizontal asymptote. I'm going to go to y equals negative 4, which is right here. I'm going to make a dot, and I'm going to make a horizontal line. That's a left and right line, like the horizon, if you can't remember. So I make a horizontal dotted line there. Okay, well now I know that if we remember back to what we were looking at before, the graph will always either be this, or it could also be like this, right? So we just have to determine where are these curves going. Okay, well that's real simple. Pick one point on each side of the vertical asymptote, plug it in, and see where it lies. It's either going to be here and here, or it's going to be here and here. There are few occasions where it could be here and here and here and here, but that's why we pick one on each side, so we know exactly where it's going to be. So I'm going to pick, in this case, one point to the left of this vertical asymptote and one point to the right of my vertical asymptote. All right, so I'm going to pick negative 1, and I'm going to pick 1. And I'm just going to plug them in, and I'm going to test them. So I'm over here. I'm going to plug in negative 1, and I'm going to plug in 1. Remember, I got these 2 points, the negative 1 and the 1, from picking 1 point to the left and 1 point to the right of the vertical asymptote. It really doesn't matter where. I could have picked it all the way over here. I could have picked it all the way over here. It's just usually easier to go right past the asymptote. So I'm going to take the negative 1 and I'm going to plug it in here. So I get 2 over negative 1 minus 4. Well, 2 over negative 1 is negative 2, and negative 2 minus 4 is negative 6. So I would have the point negative 1, negative 6, which is all the way down here. So that's going to tell me that right here, seeing as my point is this way, right here, that my curve is going to be on this side. I'm going to get closer and closer to both of those asymptotes, but I'm never going to cross it. Again, the curve really doesn't need to be perfect. As long as you get to one point there, we can make the rest of the curve. Okay? I'm not really too worried about how great this curve looks. I'm more worried about, do we know where the curve is and where are the asymptotes. As long as you know that, then that's perfect. So now I'm going to do the same thing with 1. I'm going to plug 1 in. So 2 over 1 minus 4. 2 over 1 is 2, and 2 minus 4 is negative 2. So I have the point 1, negative 2, which is right here. And again, like we see, this is in this part of the dotted lines. So I'm going to have my curve just go like that. Again, getting closer and closer to the dotted lines, but never crossing them. And then this would be my graph of the function y equals 2 over x minus 4. So when graphing it, you have to do two things first. You have to find the vertical asymptote, and you have to find the horizontal asymptote. Once you find those two things, pick one point to the left, one point to the right of the vertical asymptote, plug it in, and see where your curves are. They could be here and here, they could be here and here. And like I said, on very few occasions, they'll be both on top or both on bottom. There could be occasions, though, where they are like that. Let's do one more together. So let's say we had the function y equals 1 over x plus 1. Okay? So again, we want to find the vertical and the horizontal asymptote. I'm going to start with the vertical. I'm going to take the denominator, x plus 1, set it equal to 0, and solve. Subtract the 1, so I get x equals negative 1. So my vertical asymptote, and I'm just going to shorten it to VA, is going to be x is equal to negative 1. Okay. Now my horizontal asymptote. Horizontal asymptote is what's added on to the end, or subtracted to the end. Unfortunately, I don't have anything here, so what does that mean? Well, that just means that my horizontal asymptote is going to be y equals 0. If nothing is being added to the end or the beginning of my fraction, nothing is correspondent to the number 0. So my horizontal asymptote is y equals 0. Okay, now I go to graph it. Create my chart, or my xy plane here. I'm going to first graph my horizontal and vertical asymptotes. So I'm going to take the vertical asymptote of x equals negative 1. So I go to x equals negative 1 right here. And I create a vertical line up and down. Then I go to where y equals 0. And I create a horizontal line. Okay. So now, like I said, I'm going to take one point to the left and one point to the right of the vertical asymptote, and I'm going to test it. So in this case, I'm going to test the point negative 2, which is right here, and I'm going to test the point 0, which is right here. I'm going to go to my chart. I'm testing the points negative 2 and 0. So I'm going to plug in negative 2. So when I plug in negative 2, I have 1 over negative 2 plus 1. Well, negative 2 plus 1 is negative 1, and 1 over negative 1 is just negative 1. So I have the point negative 2, negative 1, which is right here. So again, that tells me that my curve on this side should be right here, getting closer and closer to both asymptotes, but never touching it. Then I do the same thing with 0. I plug in 0. I get 1 over 0 plus 1, which is 1 over 1, which is 1. So I plot the point 0, 1. I create my curve, getting closer and closer to both asymptotes, but never touching it. And that would be the graph of y equals 1 over x plus 1. All right, so again, I've got three different rational functions up here. I'd like you to pause the video for about 5 to 10 minutes. And for each one of these three, I want you to first find the vertical and the horizontal asymptotes. And then once you find the vertical and horizontal asymptotes, I would like you to try to graph it. Just remember, graph the vertical and horizontal asymptotes first, then just pick one point on either side and plug those in to determine where your curves will be. So again, take 5 to 10 minutes, try these three problems on your own. Okay, so here are your answers. I know it's a lot of color and very colorful here, but try and focus on one at a time. So for this one up here, for this first one here, taking the denominator, setting it equal to 0, don't have to solve anything, so my vertical asymptote is x equals 0. There is nothing being added or subtracted to the end, so the horizontal asymptote is y equals 0. So I create my horizontal and my vertical asymptote here and here, and then I pick one point to the left, one point to the right. So I pick -1 and I pick 1. Plug in -1, -6 over -1, that's going to be 6. So I have the point -1, 6, which is right here, and that's in this quadrant. So I'm going to create my curve up here. And do the same thing with 1. Plug it in, -6 over 1 is -6, so I have the point 1, -6. So my curve is going to be here. All right. Same thing over here. Take the denominator, set it equal to 0. I should get x is equal to 3. Nothing's being added onto the end, so I get y equals 0. Create my vertical and horizontal asymptotes. Take one number each from the left and the right. So I'm going to take 2 and 4. Plug in 2. 2 minus 3 is -1. 1 over -1 is -1, so I have the point 2, -1. Take the point 4, plug it in. 4 minus 3 is 1. 1 over 1 is 1, so I have the point 4, 1. And as we see, points here and here. I'm going to make my curve right here, and this curve in this one. And then same for the last one. Take the denominator, x plus 2, set it equal to 0. I get x is equal to -2 as the vertical asymptote. Here I do have something added on to the end, so plus 1, that's going to be my horizontal asymptote. So I create the vertical and the horizontal asymptote, pick one point from the left and the right of the vertical asymptote. So in this case, I'm actually picking -3 and -1. When I plug in -3, -3 plus 2 is -1. 2 over -1, excuse me, is -2. -2 plus 1 is -1. So I have the point -3, -1 right here. So I create my curve in this point, or in this quadrant of the dotted lines. Take the -1, plug it in. -1 plus 2 is 1. 2 over 1 is 2. Plus 1 is 3. So I have the point -1, 3. And then I create my curve from that.